Hello, welcome to lesson 33. So today's lesson is about ice core data, specifically using models to understand the effects of climate change. So lesson 33 warm-up is on Google Classroom. The question is, what kinds of information can scientists get by looking at ice cores? So for this question, please use your own words and ideas. Avoid using Google. I know it's been a while since we last looked at ice cores, but yeah. If you need some help, look at the picture. It'll help you figure out, or it'll help jog your memory about what kinds of things we can find in ice cores. So go ahead and pause the video, go answer that question, and then we will move on. So today's agenda, we just did the warm-up. Next, we're going to watch an ice cores video, and then we're going to do a little bit of ice core data analysis. So today's goal is by the end of today, you're going to be able to use a model to evaluate changes as a result of climate change, and analyze data for patterns. The focus question for today is, how will climate change affect the stability of humans and the environment? So basically, how is climate change going to affect us, humans, and our environment and our planet? So we're going to start by watching a video about ice cores and melting glaciers. The video is on this. It's on this PowerPoint, which you can find on Google Classroom, and the questions that you're going to answer are also. So as you watch this video, you're going to have some questions to answer. The questions are on a post called Lesson 33: Ice Cores and Melting Glaciers Video Questions. Apparently I can't share my screen, otherwise I would show you what this Google form looks like. But this Google form has 4 questions. The first question is, what do ice cores tell us? The second question is, what are some social, economic, and or political impacts if glaciers were to continue to disappear? Number 3 says, the video compares glaciers to canaries in a coal mine. What does the video mean by that? So I'll just quickly tell you that canaries in a coal mine. Canaries are birds that miners used to use to tell them when a mine was filling with some poisonous gas. So the miners would put canaries throughout the mine, and if they noticed that a canary was freaking out or looked kind of sick or was dead, then the miners knew that the mine was full of toxic gas and the miner needed to leave immediately. So the video compares glaciers to canaries in a coal mine. What does it mean by that? And number 4, why is precipitation so important to glaciers? So you're going to answer those questions as you watch this video. And again, you're going to watch this video by yourself. I'm not going to play it here. All right. And then after we watched the video and talked about the questions, we did a little bit of ice core data analysis. So in this lesson, we used 400,000 years of ice core data to find clues about climate change. The data came from a research station called Vostok Station in Antarctica. And by analyzing and interpreting the data, we are going to be engaging in the science and engineering practice of analyzing and interpreting data. So in class, I showed where I got this data from, actually, here's Vostok Station. Sort of a little bit in the middle of Antarctica, kind of. But in class, I showed where this data came from. Again, I can't share my tab for some reason, and also it's not extremely important. So just know that I graphed this data using numbers that came from Vostok Station in Antarctica. Right? So what you're going to see on this graph, we have a blue line that says CO2 concentration, rounded. The CO2 concentration, we're going to read using the numbers on the left, and the unit for that is ppm, or parts per million. Remember, that's how we always measure carbon dioxide in the atmosphere. The bottom line, the red line, is temperature anomaly. So this is essentially temperature, and we're going to read temperature anomaly using the numbers on the right side. Temperature anomaly is kind of a strange way to show temperature. It's a way you probably haven't heard of before. But anomaly, that word means something different or something unusual. So temperature anomaly is the difference from the average temperature. So for this data, the average temperature in Antarctica at Vostok Station is negative 56 degrees Fahrenheit. Just kidding, negative 56 degrees Celsius, which is extremely cold. So temperature anomaly is the difference from negative 56 degrees Celsius. So if the number is 0, that means that the temperature there was not at 0, it was actually negative 56. If the temperature anomaly is minus 10, that means it was not minus 10 degrees Celsius, it was negative 66 degrees Celsius, because that's 10 degrees lower than negative 56. Yeah, this is just a different way of viewing temperature data. So anyway, in class, we kind of explored this graph. And I forgot to tell you, the years go from 0 BC all the way to 400,000 BC. So that's like, 2,000 years ago all the way to 402,000 years ago. The question, so I asked some questions. One question was, what patterns do you notice on the graph? So you might notice that when carbon dioxide goes down, temperature also goes down. When carbon dioxide goes up, temperature also goes up. That's a pattern that we've seen before when we talked about changing climates. So see, down, up, same thing here, down, up, down, up. Second, how many peaks can you identify in this data? A peak is a mountaintop. So it's wherever there's a point. On both sides of the point, the data is going down. So this right here is a peak. This right here, actually this right here is a peak. This is a peak. This is a peak. So looking at this data, you might say that you could see like 11 peaks. You might say that you could see like 5. If you say 11 peaks, that probably means you're counting every tiny little mountaintop, every tiny little peak. If you're going to say there are 5 or 6 peaks, you're probably counting all the really big peaks. But if we just look at the big peaks, which I call global peaks, so this is a global peak, this is a global peak. You might say this altogether is a global peak, this is a global peak, and this is a global peak. So that's 5 global peaks. We can do the same thing with troughs, which are all the bottoms, all the valleys. So again, you might say there are like 10 or 11 troughs. You might say there are 5 or 6 troughs. It just depends on if you're counting every single little one or if you're counting only the really big ones. But the reason we're counting peaks and troughs is because we can determine the approximate length in years of one cycle. So when we talked about changing climates, we saw that carbon dioxide and temperature, they kind of have a cycle, right? They go up and then down, up and then down. And the time it takes for carbon dioxide and temperature to go up, down, and then back to the start point, that's called one cycle. So we can find out the approximate length of one cycle by looking at the global peaks. So for example, if we look at this global peak all the way to this global peak, we can see there are about 75,000 years between those. Look at this global peak to this global peak, we can see there's about like another 75,000 years. From here to here, we've got 100,000 years, and from here to here, we have about 125,000 years. So on average, the approximate length of one cycle is 100,000 years, on average. So it takes 100,000 years for carbon dioxide and temperature to go up, down, and back to the starting point. Of course, this will probably be a little messed up because of the amount of carbon dioxide we humans are adding to the environment. But naturally, about every 100,000 years, it seems like carbon dioxide goes up, down, and then back to the starting point. Right, so that's all we had for class today. Do make sure that you watch the video and fill out that Google form. But otherwise, I will see you in class next time.